Hey, happy Sunday, data science streamers. Very excited to be here. Having a little discussion of daylight savings versus standard time always confuses the hell out of me. I think we're in standard time in the northern hemisphere and maybe daylight time in the southern hemisphere, but that's not what we're here to talk about. This stream is not about times in different hemispheres. This stream is about data science, so welcome to some Sunday afternoon data science. What is time? That is a good question. But this is not a stream to ponder deep questions about time. This is a stream for Python and SQL and data science. And for those of you who don't know or haven't been on this before, my name is Carl. I'm a data scientist in Silicon Valley. As you can see, I'm still experimenting with the new camera, trying to find a good way to do the camera. I do like the chroma cam background. I'm not, the hidden background, so I'm just like floating here. I'm not sure if the camera is what crashed my stream last week. It might have been the camera, or it might have been Microsoft Excel. I always blame everything on Microsoft Excel, if you're with me. So, without further ado, I'm going to go into my usual stream routine. Start by explaining what is churn. This is to give the background for everyone who's never seen this in one of my streams or somewhere else before. Churn is subscribers, customers, or users who quit a product or service. And that's what we're here to talk about. It applies to all products with recurring revenue or repeat customers. Whether you have a paid subscription, in-app purchase, or an ad-supported product, it's still churn if your users quit. It comes from a term called the churn rate, which is the percentage of customers or users that drop out or don't come back in a given time period. I did an earlier stream on calculating the churn rate. You can find it in the history if you want to check it out. Churn is also a verb. You can say the customer churned, or even I churned, or I'm churning from, Hulu or Netflix, because I never watch those damn things. Truth is, I like to read books, not watch streaming services, so I'm kind of old school that way. There's no, anyway. You can also use churn as a noun. And the term churn is from the butter churn. That's the most common use in the English language. And speaking of the butter churn, here it is. I drank so much I churned. I haven't heard that one, but I'm going to start using that. It does sound kind of like that. Anyway, this is the butter churn. In English, churning is for butter. That's like, and it just means to, turn over or spin about, because when your customers are churning, your customers are turning over and like replacing each other, So let's see, what else were we saying here to give everyone the background on this subject? Yes, my camera is flipped. Well, I'm trying to get the camera thing straight because when I start to look at stuff, I want to be looking at, it has to look like I'm looking at things. So yeah, it's complicated. I'm trying to get the camera thing down. But speaking of churn, churn is probably the most common data science problem today, so if you want to learn special tips and techniques for it, this is the place. It's also a cool subject for beginner data science because on this stream we're doing one data science topic from start to end, and you start out with just basic data handling, which is like what we're doing today, and at the end we get on to all kinds of the advanced stuff like machine learning. But we start from the basics, which usually in data science they just drop a problem on you and give you the data, but here we're actually going to build up the data. What was Fighting Churn with Data? If you haven't seen, that's the book that I wrote. It's out now, Manning.com, so Manning Publications, and there's a discount code shown here. Hello, it's Peanut Butter. Welcome to the stream today. Glad people actually have some brain waves open for data science and, well, a little bit of music on a Sunday afternoon. But yeah, if you haven't, seen the book, definitely check out the coupon, TwitGold40. That coupon seems to be good forever. So everything I do on these streams nowadays is basically coming out of this book. So you actually don't need the book because all the code is free for you on GitHub. And yeah, 40% off is a pretty steep discount. It's amazing that they just give me this code just for streaming on Twitch. But so if anyone ever wants the book, definitely get the discount code. It's not going anywhere. All right, I was supposed to say, oh really, you already ordered the book. It's peanut butter. Thank you for the book order. Glad to hear that you're interested enough to read it, even after hearing me talk on the stream. So Zora is the company where I work. It's my day job. It's a very cool company because we power the businesses of many companies, meaning like the business aspect of their business. So like Zoom is a Zora customer. You see Zoom's name right here. It looks like I'm just pointing at them. And they're a Zora customer, so when you go on a Zoom meeting or you sign up for Zoom, it's actually Zora who's managing your subscription. Now, we don't power the Zoom streaming video. We power their subscription management, which means their subscribers and their subscription plans. And that's how I came to work on so much customer churn. So that's kind of where I got my background. Let me say a little bit about the goal of, I think actually everyone on this stream has already heard all this before, but I have to do this anyway. So the goal, the real Fighting Churn with Data, I mean the book is called Fighting Churn with Data, but this is what Fighting Churn with Data really means. It is making a great product by using your data so your customers keep coming back. It is targeting engagement messages to your customers so that the right customers get the right messages without spamming them. You also do customer success and support with your data, reach out to your customers, proactive and reactive assistance. And lastly, you do sales and pricing. So you want to right size your plans, like have a 3-tiered, a good, better, best plan is what they call it, so that everyone can get a value on your product and service, but without giving out discounts. Many people think that fighting churn is about discounts. It's a bad idea to use discounts to fight churn, but you can use your data to come up with a better pricing plan. That's the advice. So that's kind of the background. I like to level set so everyone knows. I'm going to be talking about code from my GitHub repo, so you can get all the code for free without buying the book. And if you're like a quick study or you already know a lot of data science, you can probably just pick it up from the code, honestly. So don't throw your money away on the book if you don't need it, but it's a great book, so it's not throwing your money away if you buy it. But so this is setup we took care of in a previous stream, and I cloned a repo, installed Python and Postgres, I created schemas, Python setup, and lastly I ran a data simulation, which is where we get the data for all the coding exercises I'm going to do today. So anyone can get this data. Unfortunately, I could not get a real customer data set to share with you to teach the techniques just because it's sensitive data, so companies won't share it. So I made a simulation and let's look at it. I always say, where's the data? Is anyone old enough to remember Where's the Beef commercials? I was just a child. I was a small child when they had, Where's the Beef? So I'm like, where's the data? I gotta dig up those old commercials. So the data for these simulations, I have it in a Postgres database. And so it's a subscription product. So this is some data from the subscription table in the database. So each subscription has an account ID. The product is just called SocialNet, is my simulated social network. And every subscription has a start date and an end date. And you can actually see that each account can have more than one subscription. So each month they kind of get a renewal. So this is the first subscription for account 1, second subscription for account 2, etc., etc. And so we generated a lot of subscriptions from a simulation. Let's see, there's some SQL from last week. I just want to see how many subscriptions there are and make sure my SQL's working. Looks like the font's too small. Hope that's legible. So I'm going to try to select from the subscription table just to see what we got here and make sure the SQL's working. Okay, so we got 54,000 subscriptions. Now, the other data is we created events, and there's a lot more events. So events refer to the things that customers do on the product or service. There's a lot more events from subscriptions, so I'll just count the events. This actually takes a noticeable couple of seconds. Several seconds. This is just running on my laptop. Okay, so we have 16 million events that generated by the simulation that's on my laptop. And let's look at a little bit more of the events. I'll do a limit 100. Let's say order by event time. So let's see. So this is what the event data that we generated looks like. It actually doesn't look much like this. It just has account IDs, times, and there's an event type. But we can do a slightly better job looking at the events if I do, there's an event type table. That's why this column here just has event type IDs. So let's just do I'm going to do an inner join. You can use an alias. So net1. I'm going to do an inner join on the type table. There's a type ID, which I use, that's what we're trying to do. So I'm going to join on the event type ID, and now we'll try selecting. And now you can actually see that the events refer to things that happen on the social network. So this event means that customer 359 posted. This event means customer 47 made a new friend. Aw, lucky customer 47, he got a new friend. Customer 2523 viewed an ad. And so these are all the things that happen on the social network. Yes, this is SQL. It's a SQL database. And so I do a lot of work in SQL. Maybe I can make this font bigger. I think I need a bigger font. Yes. All right, so hopefully everyone can see now this is very standard SQL. And I like to use SQL to do a lot of this data processing. That's one of the main themes of my book, is that we do as much as we can with SQL. And the advantage of that is you don't have to take your data out of the data warehouse or database to work on it. So let me say more about what we're going to do today. This was kind of just our what is the data. So we've got subscriptions and events are the main data we're going to be looking at. So I mentioned previously we did churn calculation with SQL. So there's streams on that. I save the highlights, and basically one of my highlights is always like the whole video. So if you ever miss, one of my streams, just look for the old highlights. So we did churn calculation with SQL, and today I'm doing metric calculation. And I know some of you watched the stream last weekend, and so this is pretty similar, but this is like a new improved version, and hopefully without my computer crashing at the end of the stream. It's pronounced SQL or SQL. I hear both. And I say both, honestly. I say sequel for short, so yeah, it sounds like the sequel to a movie. And we say SQL. I probably say sequel more commonly. And that's pretty standard for people in my company and my group. I don't know. SQL is derived from SQL. I thought it's derived from structured query language. Right? I don't know, that's my understanding, is it's structured query language, SQL, and then when people are just talking fast, they go SQL. So, anyway, so we're going to do this metric calculation, and I say in database, which is kind of what I was just referring to, that I'm going to try to, there was a first product called SQL. Now that is some interesting history that I don't know. But I don't want to go Googling for the history of SQL right now. I'm going to try to, keep talking about real SQL. Like, let's look at some. So you can use SQL to calculate customer metrics. And yes, why is SQL used? It can be done using Python. So what we're doing here is calculating metrics, which are summaries of the customer. Now, the reason I like to do with SQL, there's two reasons mainly. And they're related. I mean, it all relates to the fact that if you do it in SQL, you don't have to take your data out of your data warehouse, right? Because remember, we just said How many customer events did I have? It was so many customer events, it took several seconds to count. I'm going to count them again right now. So the reason I like to do this with SQL is because if you did it with Python, you'd have to take those 16 million of customer events out of your database and onto your server where you're going to calculate them. And the calculation that you do would be basically the same. So if you do the calculation with SQL, yes, there's a lot of SQL in the first half of the book. The first half of the book is about preparing customer metrics and also a data set. So this is talking about preparing the features, the feature engineering for the problem. And yeah, I like to do it in SQL because it's very efficient. That's what you're going to see. I tell people you might be surprised that you would do something like this with SQL. But once you learn how to do it, you're going to wonder, how you ever lived without doing this, because it's such a great way to calculate the features and create a data set. So moving forward, how do we create metrics? Customer metrics are summaries, and this is my overview of the metric concept. Okay, so there was a system from IBM, of course. Everything starts with a system from IBM in the 70s or the 80s, pretty much. All modern computer science. Well, that or Bell Labs. It's always either IBM, some Home Dell, New Jersey Research Center, or AT&T Bell Labs, where everything comes from originally. But not the concept of metrics. This is a common concept. So the concept of metrics is that we have two customers who have different event streams at different times. User 1 has this stream of events and times. User 2 has this stream of events and times. And they're all at different times, but the metrics make the customers comparable. You pick a sequence of dates shown here. These are just made up, 4-week apart dates. And then in each 4-week window, you count the number of events. So in this period, user 1 has 2, and this user 2 has 4, etc., etc. So you count the number of events per user in each time period, and that's your most basic customer metric. So it's just a count metric. So this is an example of the calculation going into really excruciating detail. Just showing that if you define one period, you can bin the events into each date. This is a simple toy calculation of a metric for a single customer, but that's not really going to do you much good. Going to the question of why do we do this in SQL, it's because we want to do this for all customers at lots of different times. So let's go to the first code listing in the book, which is listing 3.1, and it means chapter 3, listing 1. Whenever I'm saying listing 3.1 or something, it's always the chapters from the book. And you can find them all on the GitHub repo, of course. But this slide is my cue to get to the code. All right, as usual, I have too many things opened up, and I want to actually just find listing 3.1. So if you're new to the code for this repo, there's just a few top-level folders. There's data generation, which we use to run the simulation, extras, which are extras, and listings, which contain the listings. So then I go to chapter 3 and find listing 3.1. And this shows you how to run the metric calculation in SQL. So it's literally an aggregation over customers and time, as you can see here. And I set a date that we're going to calculate the metric for in a separate common table expression, a separate expression up here. And that's because I like to separate my constants from the metric code. And you also may notice that I use bind variables. That's these little variables that start out with ampersand. I think this font is too small. Can people read this? Yes, most of it. I use common table expressions, or CTEs. I use them very extensively because I think they make SQL easier to read. Let's just try like this. I think that's a little bit more legible, hopefully. So, okay. So I use CTEs. This is an example of a CTE. We're going to have more CTEs later. And this is the query, which is just a group by account ID. And there's a date set as a bind variable, and also a metric, an event name set as a bind variable here. So I think I already have a saved version of running this. What does it say? 3.star. What did I do here? Well, let me go to edit my configurations, because the way you run all these listings in my book, let's see. I guess I want to say listing 1, chapter 3, and yeah, so this is the standard way you configure one of the listings in the book. I also went over examples of doing this in previous streams. Okay, the font is fine. That's good. So when I run this SQL in PyCharm, yes, I use PyCharm, and I like to use an IDE. And in the setup instructions, I demonstrate PyCharm. But of course, you could do this with other IDEs too. So when I run this SQL 3.1 in this, I have a wrapper program for the book called Run Churn Listing. It actually is going to print out the SQL as it goes. We can step into the wrapper program later. The setup instructions are actually on the GitHub repo. To be clear, it's Peanut Butter's question. Let me just show you real quick. The setup instructions are really, let's see, this is my website, but I can go to, I have GitHub linked on here. The setup instructions are really in the README for the GitHub repo. So this is where all the setup instructions are. Make this font bigger. So these are the setup instructions, and this gives you everything you need to get going with a book. All right. Oh wow, yeah. I wanted to, MOSFET. We should talk offline, because I want to give setup instructions for Jupyter notebooks, but I'm not really like that good at Jupyter notebooks. So I am actually interested, but I want to take it offline and keep demonstrating the SQL. Okay, it's on GitHub. Yes, I'm interested, MOSFET. Please, I'll look into that later. But I wanted to demonstrate a little bit more about how this SQL works. I usually like to take these SQLs and put them actually into the SQL GUI. This first part just sets the schema, essentially. I think there's different ways to do it in different languages. But after doing this, I won't have to specify my schema anymore. And that's a Postgres thing. Most of this is pretty standard SQL, not Postgres specific. You'll see there are a few Postgres specific things, like this style of doing a cast. That's a cast from a string to a timestamp, that's how you do it in Postgres. There's an equivalent way to do it in different flavors of SQL. So I don't want to go too much into those kinds of details. But if we do this, let's try executing this metric. Oops. Oh yeah, I thought I learned that one last week. Don't have anything selected when you press the execute button or it crashes. So I'm running the SQL, and like I was saying, it's really just a group by counting the events where the event name is like, in this case, and we're grouping by accounts. And this is one example. We've got each account, the number of likes per month on this date. 97 for account 1, 2 for account 4, 44 for account 3, 95 for account 5, etc. I don't need to read that to you. And so reason number one that I like doing this in SQL is I can do all the accounts at once without ever taking the data out of the database. So that's a very great way to use SQL for your feature engineering. So the next more advanced version of this is actually to do multiple date metric calculations. And in this previous example, I was showing you the concept of calculating the metric once a month at 4 dates, 4 weeks apart, and each time you calculate the events in the last 4 weeks. Now you can do this more efficiently, not exactly more efficient. It's that you want to be more responsive, and you don't just want to measure your customers once a month. You want to measure them every day or every week. I actually advise measuring customers every week. and not every day, because every day is usually too much information. Yeah, figured that out. Anyway, so multiple date metric calculation is shown here, and you basically just repeat the calculation 1 week apart, and you end up with overlapping windows. So on the bottom, I'm showing the concept of non-overlapping windows, and on the top is if you calculate with staggered windows, I should say. And then, let's see, we get different values of the metric at intervening dates. All right, some interesting questions coming in on the chat. Max Payne Life, customer lifetime value is related to churn, and I'm going to do a whole stream about that later, eventually. It's in the book, actually. Chapter 8, customer lifetime value is related to churn because the churn probability gives you a forecast for how long the customer is going to last as a customer in the future. So I'm going to do a whole stream on customer lifetime value in the future, but I'm trying to work through the book in order. Now, regarding what It's Peanut Butter is asking, shouldn't feature engineering be done after the model returned initial results to improve them? That's not exactly the way I teach it, because, well, for one thing is you need to do some feature engineering to begin with. Because remember, we start out, and this is actually what's very different actually about my book compared to many other approaches to data science. In the start of this book, all you have is point-in-time events, and those are not features. The point-in-time events are the raw material that you're going to construct your features from. And these count metrics are the most basic features you could make. Now, It's Peanut Butter, you're right that you will do more feature engineering after you do an initial model. But where do you even do the initial model from? The model is not based on these events. The model is going to be based on the customer metrics. So we need to start somewhere. And I actually teach an iterative process where you calculate some basic metrics, and then you do some analysis of your model. You have to make a data set out of them too. And then you do analysis of your model, and then then you iterate and do the data sets. Yeah, and okay, It's Peanut Butter, you've always worked on ready data sets so far. Now that is very common when you're in data science education, and maybe in some environments you have your data set made for you. In my professional life, I mostly have to make my own data set. You just start out with a bunch of data in tables, and you've got your subscriptions and events. That's pretty much the data model here. And we have to calculate the features. And then we're going to iterate on them after doing the modeling. So that's pretty much the process. All right, so this was the concept, and I wanted to move forward to calculating the metric for multiple dates at once. And you end up like illustrated in blue and green. If you only calculate your metric once a month, you would see it like for one customer jump from 2 to 4 in this example, then back to 2. And if you calculate every week, you see it track more gradually over time. You see these intermediate steps at 3. So you use overlapping calculation for the metric. And that's illustrated also in this toy problem. And here I'm saying we have these periods that now overlap, unlike the last example. So this period is from January 1st to 28th, and this next period overlaps by starting January 8th. So this event, which is on January 12th or January 17th, these events calculate in multiple periods. So your metrics are actually kind of redundant, but that's fine. You want to update the metrics more frequently because your customers are going to change more rapidly than once a month. I teach calculating metrics once a week, but you can go to once a day or even more frequently if you have to. So how do we calculate a metric? Well, this metric calculation looks even more tedious, right? Fortunately, we've got another SQL. We'll do it very easily. I'm going to do the example by running, again, I'm going to run it first. This is listing 2, chapter 3. I'm just going to run it, and we're going to see the printout. of the SQL with the bind variables already plugged in. And then I will take my SQL, or SQL, whoops, no, I'm going to take it to the query tool, and let's look at the new one. So now I've actually got, instead of a single date in my common table expression, or CTE here, I'm actually generating a series. This is also a Postgres specific thing. You can see that I generate a series of dates, in this case from February to May, at 7-day intervals. Other than that, though, this SQL is exactly the same as the first one. Well, not quite. The only other difference is that we join on the date. So just to show you, here, let's take this out. I'm going to show you this, the sequence of dates. There's really not much to see here. So here I just generate a sequence of dates from February to May, and these are going to be the dates that we're going to calculate all the SQL for. I'm going to do a little limit on that statement. And so now we'll see, it's just like the previous version where we select events, and for each date where we're calculating the metric, we take all events that are within 28 days before the metric. So this is less than the time of the calculation for the metric and within 28 days before it. And we do all the like events. And now we have to group by account ID and the metric date so that we are actually counting the events for many customers and dates all at once. So now this is the other reason that I like doing this with SQL, is because it's just very efficient. I mean, I know it doesn't look that efficient because it's taken 40 seconds already. You guys can't see the timer. I'm kind of blocking the timer. If I move over, you can't see it anyway. There's a little timer down there. And I can see we're up to 50 seconds for this metric calculation. Hopefully I'll have some results to show you any minute now. Perfect time for a sip of tea. A little off topic. This year, due to the pandemic, there are restrictions in my country, so I'm not going to bother going to New Year's Eve party. Well, definitely studying data science is cool. And on New Year's Eve, I don't know what to do myself either. I'm going to look for stuff on Twitch. I'm going to be looking for live music on Twitch for my New Year's Eve. I've discovered some really great stuff, because I'm a music lover and not just a data science lover. But yeah, the metric table has 17 million entries. Or no, the event table has 17 million entries. This is actually still calculating. Maybe we should come back to it in a minute. It does take a little while because we're actually calculating all these metrics for all these customers at once. Let's see, what's next in the program of things to talk about? The next thing to talk about is actually, well, this is kind of like reviewing what we've done. So there's fewer metrics than events. That's one point. Because I just said, is it 17 million events or metrics? There's 17 million events. There's going to be a lot fewer metrics because the metrics summarize the events. You do a group by and only calculate one metric per account per week. So that's why I say your events are generally big data and your metrics are usually medium data. But as I'm saying right here, we do write the metrics right back into the database. Let's see if it finished calculating. All right, finally, we got some metrics. So this actually calculated a lot, because you have to remember, there's like 10,000 accounts, 17 million events, and I just calculated all the likes per month metrics for all these accounts over multiple weeks. So now you can see, this is for like account 1, you can see his metric value kind of tracks, he's generally consistent around 80. Then he dips down to 70, whoever this simulated customer is. Then account 2 has less. He's a less like per month, less of a liker. So he's tracking down at 20 or 30. So yeah, so that's calculating metrics for multiple dates at the same time. The next step is actually just to insert them into the database. That's the one thing we haven't done yet. And that is, of course, in another listing, which is going to be listing 3.3. This one I think I'll just show you, and then we'll run it. This is basically the same SQL as the last one, but now with an insert statement. So we have another table called metric, and there shouldn't be anything in it actually, but it's in the schema. Let's actually, here, let's take a look. We can say select, I think there's nothing in the metric table. All right, so nothing in the metric table. If you could see this very small text here, you'd see that the metric table had an account ID and a time for the columns. It's peanut butter. Good question. How advanced do you need to be with SQL to work with a book? I would actually say you can be a beginner. You do need to be a beginner. Like if you've never seen SQL at all before, then you should do a little preparation. But I start out from pretty basic stuff, because I mean, I consider this SQL, the actual metric calculation, to be like advanced beginner. I'd say this is an advanced beginner query because it does have a group by, so it's an aggregation. So it's not complete beginner. Then there's some slightly more advanced stuff like the insert statement and the CTE. But I teach much more advanced stuff in the book, actually. If you watched my stream on calculating churn rates, I use outer joins, which is, I would say, a medium advanced feature. But I don't just drop outer joins on you. I actually teach it to you. And the same thing with common table expressions. The first time you see a CTE in the book, I have a couple of paragraphs where I'm like, in case you never saw a CTE before, this is what a CTE is, you know, and like that. So I think you can really be basic in SQL, but not NoSQL. And then I build it up step by step. And actually, by the end of this book, you will be, I would say, intermediate. Not advanced, but if you start out this book as a beginner in SQL, you'll leave the book, I'd say, at more of an intermediate level. Have a look at the first 3 normal forms. Ooh, that's advanced. I don't even remember what normal forms means exactly, although I know I calculated it. But you know, I should really start running this SQL, because this is actually going to insert into the metric table. Let's run one. So now I need to go up to listing 3.3. I should have actually been running this the whole time we were talking. So this is just the same SQL as the last one, but now I'm going to insert it into the metric table. Let's see if it's running. And this will take a couple of minutes too, or like a minute, a little bit more than a minute. And I've also, what's new here is I've also got a metric name ID. As part of the insert statement. So I need the account ID, the time for the measurement, an ID to identify the metric, and of course the value. And these all come out of the SQL, the group by, and I've just inserted, I've hard-coded the 0 into the insert statement. And then, let's see. Oh yeah, and it's all done using bind variables. So this is like the bind variable for the new metric ID, and this is the bind variable for what event we're measuring. And this will actually run for, again, I think like 1.5 minutes or something like that. First you click and then you press the SQL button. That's all you need. Let's see. Well, this we already looked at. Let's see, what's next in the program is talking about, metric name insert. Right, and that is because after we run the SQL, we also need to insert into the metric name table. But this is running the insert still. Had an entire semester of Access, Microsoft Access. MS Access is fine to begin. Yeah, I think the truth is, I mean, SQL is a standard, so the differences are pretty small compared to what's in common. And I try to point out when I'm doing something Postgres specific. But I did choose Postgres because it's an open source database, and out in Silicon Valley we really like open source tools whenever possible. That's for the software company business model requires you to use open source, or else you'd have to pay Microsoft just to run your product. Let's see, there's still no result on this, but let's look at the next SQL. Is actually the metric name insert. That's a pretty simple one. We can just look at it real quick right now. And it's just a simple insert because I've got a metric name table to keep track of what metrics correspond to what IDs. So this is a simple insert we'll run when the first metric, it's done. Okay, the metric finished. Sorry, I didn't mean to be like, but all right, so the metric finally finished calculating. And now if we select star from metric, we actually get a result. There we go. So these are the metrics that we calculated. Whoops, I didn't mean to sort them. But, so there's our new results. And how many metrics did we just insert into the table? So this is the great thing about calculating your customer metrics in SQL, is you just can calculate them and already they're right back in your database. So back to It's Peanut Butter's discussion of why do this in SQL rather than Python. Well, if you did the calculation in Python, you'd have to pull all the data out down to your local machine. You'd have to do all these calculations, probably in a for loop in your code, which is not that fast in Python. And then you'd have to insert everything back into the database. But by running this in the SQL, I've just inserted 163,000 measurements into the database. Okay, I know that took like a minute or 2 minutes, but that's pretty good for 163,000 customer metrics. And this is all on my laptop, people, not a supercomputer. So that's why I like doing this with SQL. So next we're actually going to do a lot more metrics. That's actually the next part. So we've got metrics for all the other events. Yeah, running everything locally in Python can definitely make you sad. So let's see. We want to calculate all the other events, metrics for the other events, which are, let's see, if we look at event type, you can actually see, nope, and what is it called again? Maybe it's just event type. What is the name of my own table? There it is. All right, so we have all these events. We have posts, new friends, likes, add views, dislikes, unfriends, messages, and replies. So we want to calculate all the metrics for these, and I'm just going to run it in a loop. Running everything locally in Python is really sad. It is sad. And that's the, what do you call the sad guy emote? Cute. So I'm going to start this next part, which is running the churn listings. And listing 3 was the insert, 4 was the name insert, and these versions I'll explain in 1 second after I start running it. Back here, I think I had this prepared from my other version of the stream last year. So this is going to be a multi-metric run. And if you, okay, no, we got to do it like this. This is how you run multiple metrics using multiple listings using the Fighting Churn With Data framework. You can list the listings in series, and then there's a version parameter. I got to put that in. Version 2, 3, 4, 5, 6, 7, 8. Okay, now this is going to hopefully run a whole bunch of metrics. Let me just double check it again. Oh no, wait a second. Version, no, see, I already had that. I knew I had to double check this. It probably would have worked. Chapter 3. Okay, yeah. All right, I'm good. Let's see, doing it in Spark would be different. PySpark. Yeah, definitely if you did it in Spark, then you're in a big data framework. And you'd presumably be running it on a server. So So let's just try, I'm gonna run all these metrics. Now, why did I do this versioning thing? I ran this versions 2, 3, 4, 5, 6, 7, 8. Now this is for the, I'll explain how this works by showing you a little bit in the configuration of the Fighting Churn With Data code. If you dig around, this isn't really explained in the book. This is kind of going under the hood. There's a configuration directory in the listings folder with, let's see, these are, let's see, the listing configurations, and it's a JSON. So if you don't know what JSON is, it is, well, it's JavaScript object notation, technically. Sorry, throwing out the acronyms, SQL, JSON, but you know, this is a programmer's life and a data scientist's life. So JavaScript object notation is a format for describing nested objects, where each object is contained in the curly braces. So all of the bind variables, so remember all these listings we were looking at have these bind variables, starting with parentheses. This is the event and the date. So the values to put in all the bind variables are stored in this configuration. So in chapter 3, if I go to listing 3, which is the count metric insert, I've got all these other versions, you know, one for each event to measure. Yes, exactly, Rodrigo. 96. JSON is almost exactly like a dictionary. Well, there's a direct translation from any JSON to a Python dictionary, which is why it makes it very easy to work with. Yeah, well, you could have lists in these too. Let's see, do I use any lists? You can have lists in these. I don't actually think I use lists in my own configurations. Oh, yes, I do. Look, here is a configuration that contains a list. So this would convert to a dictionary where the element is a list. So so the elements of JSON can be lists, strings, numbers, or other nested objects. But it still all translates directly into a Python dictionary. I should have I'll put a breakpoint and show you guys the next time we run one. Let's see how this is actually doing. So this is the first metric. Is it? It's running. Okay, it has done a result. This is the second metric that's running. Just trying to keep track so I know when it's done. So these are still running, and it'll probably take 5 or 10 minutes to do all these metrics. It can be less than you think. But so basically, what my configuration did that I was showing you at the start is I said it was listing 3, and then I said all these versions. Okay, another one just finished. So it shows all these versions, and this is to calculate the like metric. This is the new friend metric. Version 3 is the post metric, etc., etc. So it's going to run through these calculations now, and maybe we can see if any of them are done. Although I think it actually commits everything when it's all done. Let's see. I want to try, let's see, metric. I want to do a summary of what we've calculated so far. And I think actually they're not all going to show up in there until, oh no, they're showing up, look. All right, so these are the metrics that I've successfully calculated, 0 through 4. And we can also do an inner join on the name table. Inner join, name n, let's see, m dot, and so we join on the metric name ID, and here we should calculate metric name. So we'll see how many we've calculated of each metric so far. So we're making some decent progress. Uh-oh. Well, that's taking a little bit longer. Oh, you know what? Maybe this isn't working because I haven't done the metric name inserts yet. That's right. Let's see. Yeah, we're up to 5. Well, we'll have to wait till it's done because it's doing all of the metric inserts first. I actually forgot this about the order. It's doing all the metric inserts first, and then it has to do all the metric name inserts. Anyway, so calculating tons of metrics. We just have to wait a few more minutes for this to be done. 6, I think it only has to go up to 7 because we started at 0. So one more metric. And this is fairly quick, I think, too, considering it's, like I said, 10,000 customers, 16 million events, maybe, 1 or 2 million events of each type. This is a pretty efficient calculation. But when you get up to this part in the book, oh, they're good. It's all done. So when you get up to this part in the book, this is a good time for a coffee break. This is like somewhere midway through chapter 3. So let's go back to the join on the metric name and see if it's working. There we go. So these are all the metrics we calculated. We calculated 160,000 ad view per month metrics, 153,000 dislike per month metrics, etc. So here we've calculated all those customer metrics. Great. What's next? What do you do after you calculate a bunch of features in your data? What's next? Well, it's got to be some quality assurance. Okay, so this was running the metrics. That was my reminder to actually, run some code and don't just talk for the whole stream. Now, the next thing you do after you run some metrics is you do some quality assurance. And we're going to spend the next section of the stream doing some playing around with the quality assurance. So this is the first quality assurance that I teach people to do, which is a time series of the statistics of your metric. So this is looking at the maximum value of the metric, the average of the metric, the minimum of the metric, and then the count of customers that have the metric value. And this is a good way to just visualize your metric after you created it, just to let you know, are there any extreme outliers, either high or low? What's the average value? How does the average value change over time? And lastly, how many customers got the metric? So how are we going to do this? Well, another SQL, because to select the data. Here we're actually going to get into some Python too. So listing 3.6 is the SQL that will select those stats. So let's look for one. Close all these up and let's see. Whoops. A little hard to get the project window open there. I should leave it open and cracked. So this is the SQL that I use to calculate those stats of the metrics over time. Again, now it's using more common table expressions. This first common table expression generates a series of dates that you're going to use to calculate these statistics. And this is the same series of dates that we calculated the metrics on. Next, there's a common table expression which selects the metric itself. And this is just pulling out the necessary values. And for me, this is kind of like a step for clarity. You could actually merge this with the next join. Now, the interesting part of this SQL is in the statistic calculation, we do a left outer join of the metric on the calculation date. And then for each calculation date, we do the stats. But why do we do a left outer join and not an inner join? That is in case your metric calculation failed on one date and there are no values. I'll illustrate with an example in a few minutes. But first, maybe we should just run this. Let's see. Let's go back to running a single listing. Here we're going to run chapter 3, listing 6. And it's going to make those stats. And I think it's just going to save them out, actually. Yeah, pretty simple. So this is just, again, the average metric value, the count, the min and the max over time. Let's see, and I'll show you the result. It's actually going to be in a file. Oops, I don't have the file browser open. Let's get this in here. So this is where my result just came out. And whenever I mess around with Excel, that's when my stream is really at risk of crashing. Seriously. Actually, I think this is like not working. What happened here? Let's see. So this is supposed to calculate the likes per month over time. And let's see. I think it actually failed. Yeah, this is failing. Uh-oh, live debugging. Here, let me show you all what I'm looking at. I don't know what just happened. I thought we calculated all the metrics. And now this is what I got in my results. Nothing calculated. That's not good. All right, time for some debugging. I'm probably just running this the wrong way. Why is this not working? Do we have a metric named like per month? Yeah, I thought we just did all this. Am I in the right schema? Oh no, we don't have like per month. How did I not have like per month? Oh, that's my problem. I'm running this for the wrong metric. Now this is actually the perfect. Oh, my playlist is actually just from Spotify. It's like the streamer music on Twitch. Anyway, okay, I just failed, and the reason is I didn't insert the like per month metric. So first I need to backtrack and rerun that one metric, because I don't like missing one. I need to rerun version 1, because apparently I never inserted this. Let's just run that in the background real quick. And let's try to do the QA on a different version, because I've got other versions of the QA. If I just go to my configuration that I was just showing you, yep, definitely there are very skewed distributions here for those of you who have already done some QA. So I'm trying to show you how to do this with the book code. So for listing 6, I can go to version 2, which will be the new friend per month, for example. So if I just go into this listing that I was trying to run, which was 6, and I'm just going to do dash version 2, and then we should actually get a result. I'm just going to run that at the same time. All right, now here's the result, hopefully a better result that we were hoping to get from the next metric QA. Let's see. Whoops, these screens are all opening outside in the wrong window. All right, so here's the result that we're supposed to get from a QA if you've actually calculated the metric already. So here you can see the average new friend per month, the number of customers that got a non-zero value, the minimum and the maximum calculated for the metric over time. Now, if you compare that to this other one, this actually illustrates why I do the outer join, which is because when you do the outer join in this query, you get a result for every date, and I can see that 0 were calculated on every date. Now let's look back at the query. If I did not use an outer join, and this is the outer join that I'm talking about, on line 12 of listing 3.6, I used date range left outer join. This is a slightly more advanced SQL topic. This is because when you do a left outer join, you always get a result for every row in the table on the left, which in this case is the date range. And that's why in this result, there's a result for every date, even though there are no metrics. If I did an inner join, you would actually not get any results. And this is very useful for when you're missing just one date. Let's actually see if this first metric calculation finished. Yep. All right, so now we should actually be able to run the first version of this, not version 2, and get a real result this time. We should actually run all of them. But the next step is also to plot it. That's actually here. So after you get one of these query results, you want to do the visualization. So this will be the first Python listing. So this is kind of the back to the question of like Python versus SQL. I pretty much use SQL for my data work in the database. Yeah, Maddie Two Shoes, that was JetBrains IDE. Wait, is it JetBrains? Yeah, it's JetBrains. PyCharm is JetBrains. I was confusing this in the other streams. But yeah, PyCharm is from JetBrains. Let's actually go look at it. So we want to look at listing 3.7, which is the listing which will plot that data that we just saved. So 3.7 is now our first Python listing. And look, there's a breakpoint. Let's debug it. So first I want to run the right listing. So I want to do listing 7, chapter 3. And this is just going to make the visualizations that we were looking at. Let's see. So here I am. Cool, you use DataGrip. Okay, I actually don't know DataGrip. I'm familiar, I've heard of PyCharm. I know people use VS. And also I think like IntelliJ makes a Python editor. But anyway, so here we are. The way this listing works, this is the visualization to create the plots. So remember I said you want to visualize the data like this. But what I showed you so far was just a SQL result. So this basically loads that SQL result into this data frame. So this is using pandas. And I can show you, this is the result that we just looked at. It's just one of those little tables of the number of calculation dates, the average value of the metric, the number of calculated, etc., etc. So we load it up, and then we make the figure. Let's see, the figure is actually showing on my other screen. I can like bring it in over here. Let's see, and then we step through, and we're going to make the different subplots using Matplotlib. So this is a pretty simple, Python plotting function. I think we can get rid of this one for now. Go back to seeing the whole thing, and then I save the plot out. And that's pretty much it. Let's take a look at the output. Let's see, this is the last file we got. Whoop, opening in the wrong screen again for you. Let's move it over here. All right, so here's the QA that we got for like per month. Now, I want to do some more examples of showing you the value of doing this kind of QA. We're going to now start messing with the data so we can actually get a more interesting result. We're going to go and delete all of the likes on one day, and then we're going to rerun the QA. So and that's going to, I hope, demonstrate the value of doing this more clearly. So we've got these likes per month. Let's see. I want to actually now do a delete. I haven't actually done this for a while. From metric where metric name ID equals 0. I think that's the likes. Actually, a good strategy I always find with delete is to start with a select. And we also want to do a specific date. And let's see, what were the dates in those? Okay. I might have to date equals, let's see. I want to select all the metrics for one date. Let's see if this works. Metric, oh, is it metric time? Let's try this. All right, so these are all the metrics for one date, only on the 23rd. And now let's actually just delete. Let's delete them. So I'm only going to delete the metrics for one date, remember, although we have for lots of dates. All right, cross my fingers I'm doing this the right line. Oh, is it delete from metric? There we go. Okay, so I deleted a bunch of metrics on just one date. Now let's see what happens when we rerun the QA. And this, I hope, will illustrate the value of using this form for the QA. So we want to rerun, let's see. I want to rerun listings 6 and 7 for chapter 3, which should recreate that metric QA and visualization. I'm just going to run it right now. This is going to save that result in a file and then run that script. And let's see what we get in the result. Aha! Here's the new result. It's already opened. And now, look how remember we deleted 1 week of the data. And you see there's now a hole in the calculation for that. Yes, well, definitely Maddie Two Shoes. I tell people to do a lot of auditing and quality assurance of your data before you do your analysis, because I'm trying to teach people what you're likely to face in a real set of data, like from a real company's server. And there's usually a lot of junk. And this illustrates how you can detect days when the metrics completely failed to calculate. And the reason this works is because of that outer join I was talking about. So remember, when we select these statistics, I'm going back to that SQL. Oh my God, if I can even find it. I think it's this one. Yeah, so in this SQL, no, this is not it. All right, sorry people, wrong one. This is it. So it's in this SQL. Remember, I do a left outer join, and that's so that we get a date for every day that we want to. If we did an inner join, what would happen? Maybe I can actually illustrate that. Yeah, let's try to illustrate it. Here's the left outer join approach. I'm going to just put this into the query editor now. So this way, when I've done a left outer join, I get this result on the 23rd. And you can see clearly that I had no metrics and I have null for everything. But let's watch what happens if I do an inner join. Okay, let's just do inner join. And who knows what's going to happen. So remember here we have this missing result for the 23rd. And now that I'm doing an inner join, what happens? I go straight from the 16th of February to the 1st of March with no result for the 23rd. So that's why I teach to use an outer join on this particular QA, because that way, if you completely fail for a day and you do an inner join, you won't even notice. You'll just kind of like be eyeballing this. You probably won't notice that you missed a day. But when you do the left outer join, it forces you to do, really clear QA. Let's see, that's why a violin chart blocks plot would show more. The min, the max isn't that good. Yeah, it's true. Okay, I mean, this is just a basic QA here, I admit. So definitely a cool way to do this would be with more advanced charts. Generate series to have a full date range. Well, I have the date range here, so I use generate series to have the full date range. But then the key is if you do an inner join, you're on your events, or your metrics rather, you're gonna drop when you don't have it. Now I want to do one more cool illustration of this next. So we did this looking at listing 3.6. Now we looked at the pie plot. Now let's look at what happens when you have missing event data. So I showed you what will happen if you completely don't calculate a metric for a day. I'm not exactly sure why that would happen. What's really more likely is you're going to have missing event data. So next we're going to delete some of the event data. Chapter 6. Yes. More QA later on in the book. So let's look at what happens when you delete some event data and you have a missing event data and what that does to your metric. So I'm going to go back here and I'm going to do some more deleting. Let's see. So here I was doing, from event, I want to do event type ID equals 0. And let's say event time. I'm going to delete a whole month of events. So let's say from 03, 01, and I'm going to pick another date about a month later. We'll just say 0401. And let's just see let's just see if I'm selecting the right events. All right, so we got a bunch of events, a lot of rows, more rows than I actually want to see. But now let's actually delete those. So we're going to delete from these events, and then we're going to recalculate the metric and rerun the QA and then see what happens. So should I really use event type 0? Let's choose a random one. Let's take event type 3, and I'll figure out what that is later. So deleting a bunch of events takes a minute because there's a lot of events. And it's okay to delete this data because remember, it's just simulated, right? I can always simulate some more data to make up for this later. But don't really delete your own data, to do a QA experiment. That would be kind of weird. Wow, this delete is really taking a long time. Okay, we deleted like 500,000 events, and so we were deleting event type 3. So now I want to recalculate the metric for event type 3. First, I'm going to go back to my, you know what, these are actually by name. Let's go select star from event. I'm going to see what event type 3 was. 3 was the add view event. Okay, so now I want to go back and recalculate the add view metric. Actually, I probably should delete it. Alright, so the add view metric from metric name. So we're going to delete the metric 3. Delete from metric where metric ID. So I'm doing this all to make a demo of what it'll look like if you were really missing data. Alright, so we're deleting the add view per month metric. We deleted 160,000 metrics. So now let's recalculate the add view per month metric, which is, let's see, version 4 of listing, well actually I have to check listing 3. I think it's the same. Add view, yeah, version 4 of listing 3. So we're going to rerun listing 3 version 4. Well, I can just use this one. No. Version 4, listing 3, chapter 3. Alright, so we're going to recalculate the add view per month metric. Whoops. And we don't have to reinsert the name into the table because we already took care of that. So now this is just delete. We deleted the events for a month, and now we're recalculating the metric. How many metric names do you deal with in your company? Well, it depends. I mean, my company is not always the best example. I mean, if you mean Zora, their own metrics. But for a typical company that I do a churn analysis with, there are usually dozens of events that they're tracking. Maybe as many as like 100 or a few hundred for the kind of companies that I work with. And so that's how many events you have underlying the metrics. Then the number of metrics you calculate, it depends. Usually I start out with one per event before I've done any analysis because I don't know anything about them or what's most appropriate. So usually I start out with one metric per event. So you'll end up with dozens of metrics. And then I usually cut out a lot of metrics and I rework a lot of them. And at the very end of your analytic process, you usually want to have fewer than 20 metrics, ideally around 10. And that's because that's about as many as like your humans, your humans who are going to work with it are going to work. Oh, it's Peter, it's after 1 a.m. Night. Whoa, are you like in Europe? Well, thanks for joining, Maddie Two Shoes. Great to have you on the stream today. Pleasure answering your questions and talking with you about stuff. So, hope to see you next time. Right, so okay, well, it looks like we finished calculating this metric. But just to wrap up, so generally we will have, dozens of metrics that we're working with throughout the analytic process. And in the end, you want to get it down to a core set of about 10 or a dozen that are the most important. So now let's recalculate the QA for this metric, the ad view metric. Now that we have, we deleted 1 month's worth of the event data, recalculated the metric, and now we're going to rerun the QA. Let's see, I think it's, okay, listings 6 and 7 this time. Let's see if that's right. So we should be calculating, the stats for ad view per month, and then we're doing the diagram. Let's go back to the folder. Here's our ad view per month. All right, so now look what happened. Once again, after deleting, I deleted data, and then I recalculated the metric. And now you see an even more dramatic behavior. Because remember, I deleted a whole month's of event data. And I think it was from what? I did February 1st to March 1st. And that should line up with the dates. I did March 1st to April 1st, it looks like. Because the average and the count, they start to go down. The average starts to go down when the data starts to be missing. Because remember, we're calculating a 4-week total of the events. So when missing data starts on March 1st, then that's when all the averages start to decrease. Eventually, in this case, we do have a week when no one even gets a metric value. Yeah, it's because I deleted a whole month. I deleted 31 days of metrics, and I'm calculating a 28-day trailing history in the metric. So this shows how when you're missing that data, the averages will go down, and then after a time, the number calculated dips too. And here you see on this 1 week, we actually didn't calculate any metrics. But then once the missing data finishes, then we start seeing, recovering, and then the average starts recovering until it's back up to normal. And so this is the type of problems that you would see if you really had bad data or missing data for the product or service that you're running this for. And so this is really common in real systems. Now in my simulation, I made a simulation for the book. The simulation actually doesn't have any missing data. I didn't mess it up to make it hard for people to learn the techniques in the book. I wanted to give you like an easy data set to work with. So I give examples of doing all this QA, but I wanted to show you this because this is what it'll really be like in your own data if you have bad data. So that's why we do these QA tests. So I think that's mostly what I wanted to show. So I showed you this is actually a case where they never quite got to 0. But you can see this was the case I make in the book where we're missing some events from a certain date, and then the max and the average fall, and the number of calculated fall, and then you recover. So this is the pattern that you would see if you were ever missing data in your own real, your own real product or service. So I think that's mostly it. So we reran listings 3.3, 3.6, and 3.7, making bad data. That was that whole segment that I was just doing. And I think that's about it. That's pretty much what I've got prepared for today. Oh yeah, summarizing metrics. No, there's one more thing I have prepared. This is a table showing you a nice summary of all your metrics. So before we were doing a time series kind of quality assurance. So you can see problems that occur in specific points in time in your data. This gives you a nice summary of the metrics, and this is just the first summary of the metrics that you'll make. I give more ways to summarize metrics later in the book. This one is actually from chapter 3, MOSFET, and there is another version of this later. This is the first version right after you first calculated the metrics and before you made the data set. So later when you put it, well, in the next week's streams, I'm going to go over this, putting the data into a data set. This is still just on the metrics in the database, right? And the most interesting thing in this one for me is that this column in the middle, the percent that has the metric. You can see this one I'm trying to point out. So yeah, here there's no percentiles, and it's the percent of customers that get the metric. And also I throw in the average, the min, and the max. And so this is just, the percent that has the metric is important to just test. It tells you about how common the event is and if there were any other problems. So this column here gives you the percent with the metric value, which is a good test. When you the first time you calculate a metric, you want to be like, hey, did all my customers get it? Because, well, when you looked at this QA, we're showing here like the number that got it calculated, but that's different from showing you the percentage that got it. So I say to look at the percentage because that's like a different kind of relative information. So now this one is listing 3.8, and as you're probably suspecting, this is another sequel. So we'll just go right to it. Edit this up a bit. So we're going to go to listing 8. Chapter 3. I'll just run it straight up. Listing 8, Chapter 3, and then, as usual, we can put it in the SQL editor. Just take a closer look at it. So, this is the metric summary query, and it's pretty similar to these other ones. I'm using a date range here also, but it's just a start date and an end date. And then this CTE, or common table expression, is new because I'm doing the total number of accounts that have subscriptions active in this date range. So this query looks at subscriptions that start before the end date of my calculation. Not great naming of the variables here. So d.endDate is the date range end date, and d start date is the date range start date. S is for the subscriptions. So this is the number of accounts whose subscription starts before the end dates and ends after the start date. So, and it's just a simple number. Here, we can actually run this one. If we do, so this is just a simple count. And in this case, okay, we've got 13,719 active accounts in this period. And then The rest of the query, after we count the accounts, is to select all these stats. So the number with the metric is count distinct account ID, the number of accounts, and then divide the number of accounts by the number with the number that have the metric by the total number of accounts to get the percent with the metric. Maybe if I put that's a little bit clearer. And then we just calculate those other stats, average, min, max, etc. So this one's actually, whoops, I broke it. I was gonna say, this one's actually really simple until I broke it. How did I break it? Let's try it again. So this is a good query to do because it actually shows you if you have a reasonable number of accounts that receive the metric. So here we have the count with the metric, the total number of accounts, and the percent with the metric. And in this particular case, the most notable thing is that this unfriend per month only goes to 58% of accounts. That's kind of like the standout fact. If you look on this table, it's like 100%, 99%, 100, and then unfriend per month, we've only got 59%. So that is the one where it seems like our metric didn't get as many accounts as the others. And so that leaves you the question of like, okay, is that okay or not? Is it okay that only 59% of accounts got the unfriend per month metric, whereas 97% or more of accounts got all the other ones? So that's gets into the next kind of quality assurance we're going to do, but I think I'm actually leaving that for next week. This was actually all I prepared for today. Well, this is actually what I prepared for yesterday. Remember, I was supposed to do this stream yesterday, and then I got sick, but I'm not really prepared for the next stream, and I think that's good for today. So I think this is where I'm going to wrap it up, actually. So we did the metric coverage query, which was listing 3.8, and now I'm going to summarize what we did today and call it a day. So, as I said at the beginning, Fighting Churn is about targeted interventions, improvements to your product, engagement with your customers, and customer support and success. Events are raw data that you start out with. In this case, they come from a simulation. But then you calculate metrics that summarize each customer's events, because the events are just point in time, and they're unordered. They come in at random times for all your customers. So you use metrics to summarize the events and make your customers comparable. Metrics can be calculated in the database with SQL. That's mostly what we were looking about and talking about today. And it's very important to run quality assurance on the metrics when you're done because, well, as you can see, data can be missing, calculations can fail, and you don't want to discover that later on when you do your analysis. It's better to do it right at the beginning when you're just starting out. All right. So, just want to remind people my regular schedule is to do a Saturday morning stream and a Sunday afternoon stream. I'm actually thinking about changing up the schedule in the new year. I don't know if anyone watching has a comment on that. I think I'm going to switch, and I'm going to do a later stream on Saturday and an earlier stream on Sunday. I don't know. It's kind of hard for me to figure out the best times to stream, because I can really only do it on the weekend. But yeah, some European-friendly schedule would be good. Right, so I try to... Sorry, Mospit. So yeah, I try to do an early stream. That's my European-friendly stream. And I missed my early stream yesterday because I felt like puking. Honestly, I think yesterday my problem was I ate raw cookie dough the night before. So don't eat raw cookie dough. That is my message from my stream yesterday. But yeah, I want to keep a European-friendly time, which of course has to be early in the morning. I think it might be on Sunday. But yeah, thank you. I am basically better today. Again, I think it was just the raw cookie dough that I ate Friday night and not like a serious illness or anything. But yeah, don't eat raw cookie dough. And Yeah, so I'm gonna probably change my times next year, but I'll announce it when I do. I think this is what I'm still gonna go with for next weekend. So, oh, definitely no COVID. Thank you. Yeah, and I hope everyone watching this is healthy. No exposure to the COVID virus for you or anyone your loved ones, and hope everyone who does get exposed recovers. All that stuff. All right, but thank you for joining the stream today. Again, if you want to connect with me, connect on LinkedIn with Carl Gold on LinkedIn, or definitely follow me on Twitter at Carl24K. I give updates on the stream and on data science. And don't worry, I don't talk politics or, post baby pictures or anything weird like that. And yeah, you've been watching my Twitch stream, so I don't need to tell you where I'm at here. And let's see. Oh yeah, lastly, or almost lastly, to remind you again that there is a discount code, 40% off the book for Fighting Churn With Data with that coupon at manning.com books. And yeah, so thanks again for being here this week, everyone who watched and hung out with me. Really a pleasure talking to you and streaming with you today, hanging out. Hope you enjoy the rest of your weekend. I guess it's Sunday night, so there's not too much of the weekend left, but still enjoy what's left, and hopefully everyone's having a short week at work this week. I know I am, and taking some much needed holiday time at the end of the year. It has been a long year for just about everyone. God, 2020, rest in peace. Hope 2021 is a better one. But so, I'm out for today. Again, thanks for being here with me.
Shooting star, always craving for you to come to me. Though this way of life, no, it ain't healthy, but ain't no other way, it's just what I need. I want all your soul, I want your body. I'm the type that licks her play clean.